Hello, geometry students. Today we're going to continue on with our triangle congruence or congruent triangles. But we're going to try to see which one of these would tell me that the triangles are going to be congruent. So it goes with our sandwich shop thing. What you want to do is your paper, you want to fold it inside to the middle or on both sides because this is a foldable. When I'm done, I would take scissors and I would cut these flaps so then I can just, boom, open it up. We're going to fill in the stuff right now. It says, can I prove these triangles congruent? So when I open my flap, you can say, you only need 3 sets of corresponding parts. Congruent in order to prove 2 triangles congruent. Okay, so you only need 3 sets of corresponding parts in order to prove 2 triangles congruent. Okay? And so the question we're asking, well, do we have correct information? So now we're going to go through and we're going to fill out each one of these parts. So this is my first one right here. If I flip it, it says side, angle, side. So I'm going to write S-A-S right here. That's side, angle, side. S stands for side, A stands for angles. So I have this when I have 2 pairs of congruent sides and an included angle. So included, this is our first time hearing this word. What does it mean to be included? Well, included means that it's in between. So whenever I'm doing these problems and I'm thinking about what it is, really the difference between these different combinations is how these letters are. So I always ask myself, well, what letters do I have? Like, is there one that's not the same? And I look at the one that's not the same. So in SAS, the one that's not the same is the A. So then I ask myself, is A included or not? If A is included, it's in between the 2 S's. If it's not, it's not. Like it's going to be on the outside. So since it's SAS, A is in between those 2 S's, it's included. So when I'm looking at my triangles, I'm going to have 2 sides with an angle in between it. That's how I know that it's included. So side, angle, side will always prove congruence. So if I have the side, angle, side, I have congruent triangles. For our next one, this is a side, side, angle. Side, side, angle? No. It looks like a side, side angle, but it's more special. The reason why it's more special is because this is a 90-degree angle. So this one we call the hypotenuse leg. So sometimes when it looks like you have a side, side angle, pay attention to see if you have a 90-degree angle, okay? Because if you have a 90-degree angle, then that's going to be hypotenuse legs. So 2 pair of congruent sides of a right triangle. And that's called my hypotenuse leg. That's what HL is. So hypotenuse leg, that is a congruent theorem. Okay? So I forgot to put yes here. Yes, these are congruent. Yes, these are congruent. So whenever I have hypotenuse leg, it is congruent. So when I have a right triangle, and the hypotenuse is marked and the leg is marked, it is congruent. Okay? Now let's go to the next one, which is very similar to this. This is the side-side angle, or the angle side-side. So let me write that down. Side-side angle. Again, I asked myself, well, what are my letters? What letter is different, if any? In this case, the A is different. Was A included? No, because A is not in between the two S's. Okay, well, if A is not in between the two S's, then it's not included. So this is different from our first one because A was in between the S's. This was a side angle side. This is a side side angle. Side side angle. Side angle side. This A is not included. Well, a lot of people remember this because this is a cuss word if you wrote it the other way, or it's backwards. Okay? So this triangle is not congruent. So that's a big old no. If you get an SSA, that is not enough to prove congruency. Our next one, what do you think this is? Side, side, side. SSS. Well, in this case, I don't need to think about what letter's not included because they're all the same. So when you have 3 pairs of congruent sides, that's a SSS, a side, side, side. Side, 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 that is congruent. So that's a congruent postulate. So yes, these are congruent. This next one. Angle, side, angle. ASA. Again, what's my letters? I see that S is the only one that's different. Well, where is S at? S is in between these 2 A's. So that means my side has to be in between my 2 angles. Angle, side, angle. So 2 pairs of congruent angles and the included side. Well, the ASA are congruent. So that's a congruent postulate. Angle, side, angle. ASA. My next one, we look at it. Angle, angle, side. Angle, angle, side. AS. Again, which letter is different? That is my S. Is my S included? No, it's not between the 2 angles. So I'm going to have 2 angles and a side marked, but that side cannot be in between those 2 angles. So 2 pairs of congruent angles and non-included side. So this is my angle, angle, side, and this postulate is congruent. So that's another yes. And my last one, A. Angle, angle, angle. Angle, angle, angle. Y'all can see these don't even look the same. Cannot prove congruent. They may be similar though, which we'll talk about later. But angle, angle, angle does not prove congruence. And this makes sense. The best way for me to describe that is if you ever had equilateral triangle, I can have an equilateral triangle with sides 3 and all their angles are 60 degrees. I can have an equilateral triangle with sides 5, and all of the angles are 60 degrees. But those two aren't the same triangles. So these are my postulates. So when I'm looking at how I mark triangles, this can tell me if they're congruent or not. When I look, I want to pay attention. Are both of the triangles marked the same? They both have to be marked the same, meaning they have to be the same combination. Like they both have to be a side, angle, side, or angle, angle, side. They have to have the same markings. And then you just have to make sure that it's one of our congruency postulates.